All right, number 28. In planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. If the present population of the city is 50,000, which of the following expressions represent the engineer's estimate of the population of the city T years from now? Okay. So this here, if you look at the answer choices, right, it seems like all of these are exponential equation, okay, or exponential expressions. So this, what we have here should be an exponential model, right? And we know that because it decreased by 10% every 20 years. So it's not decreasing by the same number each time, right? 10% of the total. Yeah, so it should be an exponential model. And for exponential model, it followed this general format. So y equal to a times r to the t's power for exponential model, right? And a value in front is always the initial amount. Okay, that's the number that we begin with. Right, graphically, this is also the y-intercept. Okay. So for this question, we know the present population is 50,000. So that's the number that we begin with. Okay. And look at all the answer choices, they all have that. Okay, 50,000 in front. All right. And then here inside the parenthesis, that's the common ratio. That's what we need to multiply each time to go from one number to the next. Right. So this is the common ratio. And then in the modeling question, this will either be the growth factor or decay factor. So for here, we know the population decreased by 10%, right? It decreased by 10%. So it should be a decay factor here, right? So number should be less than 1. But then what we cannot do is we cannot just put 0.1 inside the parentheses. 10% 0.1, but we can't just put it in the parentheses because the model represents the total population, right? Not just the number of decrease, right? So to represent population, that's how many people we have after the decrease. Okay, so for the percentage, we have to think about if we decrease by 10%, right? How many percent do we have? How many percent do we have after the decrease? All right, so what we had to do is we had to subtract from 100%. Okay, so it's 100% minus 10%. Right? Or you can say this is 1 minus 0.1 in decimal form. Okay, and we get 0.9. And this is actually the decay factor. Okay, so that's a number that goes inside the parentheses. All right, so based on that, we can eliminate A or B. All right, so as a percent decrease, you subtract from 1. As a percent increase, we add it to 1. And that's a number that goes inside the parentheses there. Okay, so out of C or D, which one is the correct answer? Well, now we have to look at the exponent. Okay, usually it will just be t and the exponent represent the amount of time, but this one a little bit different because the population don't decrease by 10% every year, right? Decrease every 20 years. Yeah, decrease by 10% every 20 years. So whatever t is, the number of year we have, right? We have to divide it by 20. Okay, we have to divide it by 20 because if you have like, say t equal to 40, then we know that's how many increases should we have. We have to increase it 2 times, right? Because every 20 year we do it, or actually a decrease, right? Every 20 year we decrease by 10%. If we have 40 years, we do it 2 times, right? So decrease by 10% 2 times. Okay, so we have to divide it by 20. All right, so it should be D. All right, if you multiply 20t, see this will be, right, if t is like what, like 40 years we said, if you multiply by 20, this will be like what? It will be like 800, right? So it will decrease by 800 times. That doesn't make sense. Okay, that will be way too small. Okay, yeah, so at whatever t is, since is we the exponent should increase by 1 for every 20 years. So whatever t is, we have to divide it by 20 first. and that will give us the exponent on the top. Okay, so that should be our answer, which is letter D here for 28.